Good morning, my YouTube viewers. Crystal here. I'm here this morning to make another video for you. I picked a video from Driven Data, and it's the dengue fever competition question. This was supposed to be a fun competition, and they said that you can use the data outside of the website, but if they use it, they want you to put it on the blog. But I prefer to put it on GitHub, and I prefer to put it on Medium blog because then I get paid for how many people view my blog post. So I'm not going to put it on the Driven Data website because my score isn't high enough to win, and I don't actually see the point in entering a competition if your score is not high enough to win. If it was really, really high, I would enter it, but since it's not high enough to win, I don't really want to enter it because I know I won't win, and why enter it if you know you're not going to win? But we are allowed to use the data outside of the competition, which is why I decided to make this YouTube video, and I will be making a blog post as well. So this program is on my GitHub account. And so you can look on my GitHub account and you can call up the program and follow along with me. The problem statement is dengue fever is a mosquito-borne disease that occurs in tropical and subtropical parts of the world. In mild cases, symptoms are similar to the flu, fever, rash, and muscle pain and joint pain. In severe cases, dengue fever can cause severe bleeding, low blood pressure, and even death. Because it is carried by mosquitoes, the transmission dynamics of dengue are related to climate variables such as temperature and precipitation, although the relationship to climate is complex. A growing number of scientists argue that climate change is likely to produce distributional shifts that will have significant public health implications worldwide. In recent years, dengue fever has been spreading. Historically, the disease has been most prevalent in Southeast Asia and the Pacific Islands. These days, many of the nearly 500 million cases per year are occurring in Latin America. Using environmental data collected by various U.S. federal government agencies, from the Centers of Disease Control and Prevention to the National Oceanic and Atmospheric Administration and the U.S. Department of Commerce, can you predict the number of dengue fever cases reported each week in San Juan, Puerto Rico, and Iquitos? So that's your problem statement. We have 2 locations, and so we have to predict the number of dengue fever cases in 2 locations, and they give us the data. So the thing that I do is I load up my standard libraries that I'm going to be using. And the next thing I do is I load up the data sets. I put the data sets on my GitHub account, so you are more than welcome to use these data sets if you want to practice on this website. On this competition question, one good thing about this competition question is the fact that the files are not very big, and because the files are not very big, it's easier to work with. One problem I have is I cannot enter the competitions with really big files because my computer just can't handle it, and I use Google Colab to do my computations, and Google Colab just can't handle it either, and quite often it crashes. The last problem I worked on was a natural language processing problem, and the train set had several million words and the test set had a couple of million words, and Google Colab it kept churning away. It kept trying to process the data, but finally it just gave up. So that is one of the problems that you have when you're dealing with big data sets. But these aren't really super large data sets, so you should have no problem working on them. I've just got a little Chromebook with 4 gig RAM, and I'm using Google Colab, and I'm working on it, no problem. Train data set, and they give you city, year, week of year, week start date, and then a whole bunch of other variables to do with climate change. And test data set is the same thing. If you look on the Driven Data website, the Driven Data website sort of tells you what all these different variables mean. And they said that if you know about climate change and if you know about these variables, then it may actually help you to come up with a good algorithm. But I don't know that much about climate change. I don't know that much about the dengue fever. Now we have our labels, because one thing that Driven Data does is Driven Data does not include the answer with the training data set. And so what we're going to have to do is we're going to merge the labels with the training data set. And because there are 3 variables that have to be merged together, city, year, and workflow, you merge this data set on those 3 variables. If you try to merge the data set on only the 1 variable, I'm not sure exactly how it's going to work out, so I merged the data set on the 3 variables. So we look at our train info. We'll see most of the columns are floats, but you've got an object as a week start date, and an object is a city, and everything else is a float. So that's good. So you don't have to do that much ordinal encoding. So now what we want to do is we want to check to see if there are any null characters, and you can see there are quite a few null characters in the data set, in the train file, and the test file. So those are going to have to be imputed. The first thing that we do in order to solve this problem is we have to use ordinal encoding to take the 2 object columns and convert those to ordinal columns. So the columns will have numeric values instead of objects. So that's the first thing that we have to do. And we also set up a word called city equals test.city, and that's going to come in handy at the end of the program. At the very end of the program, we're going to be using this variable city. So now, after we have ordinal encoded the city column and the week column, what we want to do is I decided that we were going to replace all of the variables with median rather than mode, because in the past I had been replacing all of the variables with mode, and mode is the most commonly used answer, and I just thought, well, I'm not really sure about that. So I decided to replace all of these null characters with median, because the computer won't work if you have any null characters. Now what I decided to do is I decided to create a new column in the train file and the test file. So the first thing we had to do was we had to take the train.city and we had to convert it to a string. So I know it sounds strange, like, well, why are you converting it to a string? But that's what we had to do. We had to take the train.city and convert it to a string. And then we had to take the train.year and convert that to a string as well. And so now what we do is we create a new column, call it train year week. So train city plus underscore plus train year S type string plus train week of year S type string. So I probably didn't have to do that. I was experimenting with all of that, and I had made the week of year a string and a year a string and a city a string. So I probably didn't have to put S type string there, but that's something I did whenever I was experimenting with the best way to create this column. So that's just one thing that probably doesn't need to be put in there, but I'm not going to go through and change it now because I've already run the program and submitted it to Driven Data, and I got an okay score, so I'll just leave it as it is. But since we've already set up the S-type strings in the first 3 columns before, you probably don't need to use S-type strings here, but that was just something that I did when I was experimenting on how to create this new column. So we created the new column, and so now we've got our year week is 1.0 underscore 1990 underscore 18. So 1.0 tells you what the city is. So the city is going to be either San Juan or this other IQ in Peru. And then the year is the year, and then the week is the week of the year. So because I just thought that it would be better to break it down into cities, because we have to provide the predictions for 2 cities, and I just thought that it would be better to separate it to make sure that we've got the predictions for each city. We did exactly the same thing for the test file. And now what we have to do is we have to go through and we have to ordinal encode year week, because the computer is not going to accept it as it is. So now that is ordinal encoded. And so every year week truthfully, every year week should have its own number. Now do a graphical representation of the cities. So one is San Juan and the other one is IQ. And so what we did was we just put it on a counter to see how many of 1 and how many of 0 that you had. And now what we do is we did a displot on the total number of cases. So, there were some instances where you had well over 400 cases that week. Now what we do is we define our X, Y, and X test values. So our Y is train dot total cases values. Our X is train drop, city, year, week start date, total cases. Axis equals 1 values. X test equals test drop, city, year, week start date, axis equals 1 values. So we've defined our X, Y, and X test values. And now what we have to do is we have to split our training set up. We split it up to have a test size of 10%, and I put it on shuffle equals true, random state equals 1, and I wanted to see the values of all of the data frames to include X test. And the reason why I did that is because I made a mistake when I was working on this problem. I made a mistake. I didn't drop total cases, and it wouldn't work, and the model wouldn't work, and I couldn't figure out what the problem was. And then I finally remembered that I hadn't dropped total cases. And so that way, I think it was a good idea just to check the shape of X test as well while you're checking the shape of all of these other data frames to make sure that they're all the same. They all have 21 columns. And then what we did was we put the data on a standard scaler. You have to be sure that you fit on X train, and X train is the only one that you fit it on, and then you transform it on X train, X val, and X test. Again, you can check the shape of these data frames of X val, X train, X test, and they should all have 21 columns. If they don't have 21 columns, that means that you've done something wrong. And so what I had originally done is I originally tried to make a pipeline, but because I had made a mistake in the very beginning, I took the pipeline out because I thought, well, there's something wrong here. The mistake that I made was that I had forgotten to drop the total cases from the train file. And because I had done that, I removed the make pipeline, but you should be able to do all this in a pipeline as well. You could put the standard scaler in a pipeline and the AdaBoostingRegressor in a pipeline. And so I fit the model. I had a 99.80% accuracy, and I made predictions on the validation set, and I had a 76.95% accuracy. And so I made a data frame so you can see the predicted values against the actual values. And then we did our final labels. So I set the final labels up, and the final labels had to be an integer because that's what driven data wanted to see, because it was the number of cases. So we had to have an integer to make sure that it was S-type integer, and all of the outcomes were integers. Then we took the final result and we created a data frame to put the final result in. City, which was the city variable which I had created at the very beginning of the program. Year, which was test year, week of year, test week of year, and total cases equals final label. I submitted it, and then I uploaded the submission. When I submitted it to Driven Data, I had a 28.2043, which was acceptable. I mean, the best rate was 10. But 28.2043, it was an okay rating. It definitely wasn't the highest rating, which is why I decided not to actually formally enter the competition. But I'm sure you could do a lot more work. You could experiment more, like perhaps to try a different model. I tried XGBoost. XGBoost was slightly lower on the test, on the validation set. I didn't want to try CatBoost because I don't know CatBoost that well, and when I have tried CatBoost, it didn't work out that well. But the best model that I found was AdaBoostingRegressor with Gradient Boosting Regressor as the base estimator. I got about 1 point better with that than I did just using Gradient Boosting Regressor. But you can experiment with it. You can see that I did make just a few little minor errors, like because this said make pipeline, and then I never took make pipeline out because I took the make pipeline out, and a string right here when I could have taken that out. But that was just things that I was doing in the experimentation phase, and it didn't really affect the final outcome. But you've got the data set here, and so you can experiment this as well if you like. So that concludes this presentation. If you like my code review of my solution to the dengue fever epidemic in Puerto Rico and this place called Iquitos, Peru, And you can like and subscribe and share. If you like the work I do and you want to leave a donation, I've got my email address to my PayPal account down below. I don't have enough viewers to monetize, so I have to ask for donations to make any money on this channel. And thank you so much for watching my video, and I look forward to making new videos for you.